we just had a major blowout, and I did just let the air out of this here, so, but it didn't actually pop the tire, but it did peel off the outside. So this is just like peeling an orange right here, and this thing flopped around like crazy, and yeah, made quite a racket, obviously. So we got to take this off and try and put something different on here. Maybe we'll put something different on here and something different on there, I'm thinking. Yeah. I have to take my temporary guard off. There's nothing more than C-clamps at this point. I haven't made it permanent yet. Alright, so now we can see the tire like that. And then we have to take these off and pull the blade out. Loosen that up a bit there. Loosen this guy up just a skosh. Woo. Pulls out like that. Same thing for this one. Loosen it up. Loosen it up. One more. Ouch, wrong way. There we go. So those are on there. I don't think I really need them on there actually, but the way this thing is made, it has this structure, right, on either side, and there are some cross members underneath the blade here that hold everything together. I think they're probably, you know, overall it's plenty sturdy, at least for the tensions that I've been running so far. But these top things, they just connect everything together to give it a little bit extra stability, I guess, and prevent some kind of a warpage in here. I don't think they're probably necessary, but they are there. Big jump. All right, so I'm going to measure the diameter of this tire here. 24, 25 inches maybe. And my mark is at 76 1/4. So just 76.25 divided by pi equals 24.27 inch diameter. So that's what I have approximately. All right, so we have to check the size of the shafts here, and we're going to call that one a 2-incher. I am looking to order a couple of Bandwheels. There it is. Beautimous. All right, I'm going to leave this protective film and tape on here, just pulling this back to show you for a second what this looks like. So What I can feel is there's just a little bit of a crown on there, I think, from what I can tell. It's hard to see, but anyway, pull that back on there until I get these on the mill. So the other thing I'm going to tell you here is that when these come, they have a mark in here, an index mark telling you exactly how to put these together, and this has got to line up. Pretty simple, I guess. I don't know what just went on there, because these keyways were already cut in these shafts from before, and it appears that they will fit that perfectly, I hope. I don't remember cutting them, but maybe I did. Or maybe these shafts just were the way they were when I got them. I mean, they were in the garbage pile. So, what am I going to say? Act of God? Fate? I don't know. So from here on out, it's going to be a lot of adjustments to get these lined up, and basically I'm starting out lining them up to where I had these, I think, because that seems like a pretty good spot, and those were pretty level with the bed. So I'm going to start there, and then once I get them all lined up, I may even I'll probably end up tweaking these a little bit, because with the rubber tires I had to cheat them a little bit, and I had to add this thing here as kind of another cheat so that it didn't walk off. So that was all in the past. Hopefully this will be gone, right? And yeah, I'm starting out. You do have to have the wheels up just a little bit from these idlers here, or guides. So I'm going to tighten down this and just kind of keep working it into place, and use this piece here as a straight edge, and probably fasten it to the bottom of this all the way across once I get this halfway decent. I'm telling you that now, not to announce what I'm going to do, but in the event that I get sick of recording this halfway through and shut it off, which I may do very quickly because this is going to be extremely boring to watch. And yeah, hang tight. This side here, the adjustable side, I mean, it does have a little bit of flex in there, but I think the key is that, you know, it's wherever it's at when it's under tension, right? So I'm pulling up on this whole thing to try and mimic that a bit. And now I'm gonna check and just make sure I've got like the right distance between here and here, and here and here on the rail. Hopefully that's pretty close. Ouch, over to the other side. Let's check this here. All right, it's off by ever so slightly. So I'm not gonna worry about that because I can just tweak this up and down a little bit with my adjustment there if I need. As we go along here, you're going to see that I'll be bringing out more and more pieces of square tubing to use as straight edge, and fortunately I have a lot of it, so that's a good thing. Right now I've got these two pieces sitting on the bed here to try and extend this, extend the parallel of the bed outward to where the band wheels are here. And I've got a square sitting across here and then going upwards to try and check whether or not the wheel is straight or tram this way. You can see it's pretty much against this on the top, and down here I've got a little bit of a gap, so I'm going to take and adjust this pillow block bearing on this side probably upwards a little bit to try and bring that into tram. That's probably the more difficult adjustment, and then after that I'll try and make sure I got the right kind of a gap in here. I'm going for maybe about 1/4 to 3/8 of an inch gap here, difference between here and the roller guide, so there's just a little bit of down pressure from the roller guide. The Cook's Saw manufacturing site or their their channel on YouTube has a very good set of instructional videos as far as setting this is concerned, so I recommend going there as well if you're looking at this.
I think things that require lots of maintenance are certainly going to be a bad thing, but I can't think of anything specifically woodworking related.
Well, like a piece of furniture they don't want?
I'm at the point where I need to snug these up on here a little bit more. And with anything, when you're going around several different bolts in the same thing, it's good to kind of snug them up gently, little bits at a time, evenly, right? That should be kind of common knowledge, but sometimes it's not. I watch people crank down on one bolt and then leave the others, you know, till later, and that's gonna get you crooked. nice and even all the way around. From this point forward, I think the best way of doing this is to actually have the blade installed. So that's what I've done. I've installed the blade. Obviously have to use a little bit of tricks here just because things are not exactly kosher just yet. So I've got these clamps to hold it on and whatnot. And fortunately, the old blade that I had still works on here. So things really haven't gotten sized that much different. I did bring it in maybe a skosh, and I'm going to put a little bit of tension on it. Obviously this tension here is not necessarily blade tension, although it correlates, but this is just tension on my cylinders down there, and I got a whole different video about setting this tension and so on. So I'm going to put a little bit of snug this up on here, so that'll just make sure that it pulls everything together tight when I tighten things down. There we go. That's more tension than what I ran before, that's for sure. So plenty of tension there. And now we can start making some of these other adjustments to get things lined up. This is going to try and get the blade somewhat straight this way. So it's like all these different parts of this adjustment you have to keep working into place, right? Little by little, getting closer with each one. And this goes all the way across to the other side. And right now I've just got it clamped here on the outside. I wouldn't want to clamp it in here because it would flex it inward, right, and give me a wrong measurement. So now I'm going to adjust these on each side to try and get it more parallel one to the other. I'm at a stage where I'm trying to fine tune how the blade rides on the wheels, and what I've done is I've actually backed these off so that they're not engaged with the blade and not influencing it, because I want the blade to be able to ride on the wheels without the roller guides influencing the blade at all, and then I will put the roller guides in place and proper amount of tension and whatnot, down pressure. I've got a straight edge that goes from wheel to wheel, and I'm trying to basically make everything as parallel and even as possible all the way across here. We go across to this wheel here. And what I am finding, even on this mill, which is different, I guess, than what I thought, is that there's a little bit of a toe to it. The trick is that you're trying to get both wheels on the same plane this way, and then you're trying to adjust them this way. So there's kind of two different things that you have to work into place, and I've been doing that offline here while you guys have been waiting for the next minute. So I'm pretty close right now. I've got it where it rides more or less just to the front here, and the same way on this other one, it rides more or less to the front right here. I'm probably gonna do just a little bit more fine tuning to the adjustment, the camber, I guess you'd call it, and see if we can get that just right. And once we get that just right, then I'll get to putting these roller guides back in place. Just kind of giving this some spins in the direction of the cut. So that's actually very close to where I want it. It's riding right on the front there. This one here is riding on the front maybe just a skosh more. And so I'm going to adjust this just a bit. Tighten this side here to make that out just a bit. All right, let's try and spin this again. And I think I'm liking that pretty well. Okay, so I'm just hitting about the bottom of the gullet with the front of the blade there. Seems pretty good. Same over here. Bottom of the gullet is about even with the front of the blade. And spins nicely. So from here on out, basically I'm going to go through and tighten every last one of these bolts, these lock nuts, these set screws, and I notice that these kind of tend to loosen up a little bit over time, so I might actually add a set collar on here just for an extra bit of safety on either side. We are about ready to spin this thing over and do a little dry run here. That absolutely made my day. One thing I never thought of before with the rubber tires was having some sort of a brake on here, but this spins so easy compared to the rubber tires that there's a ton of momentum. Each one of these wheels is 70 pounds, so there's 140 pounds plus the shafts and everything that are spinning around and have momentum. Obviously, if you're still cutting, it would, stop quickly. But in the course of this thing wanting to stop in a hurry with no brake, it's going to keep rolling right along because it rolls really easy now compared to what it did with the rubber tires. That is a huge, absolutely huge difference. And my tension here, this is all relative again, remember. This is PSI on some cylinders, not PSI of the blade, obviously. So, number just is what it is, right? But before, at most, I could run about 600 PSI on here. I'm up to 1,000, and it's tracking absolutely beautifully. With that, I gotta put a couple more things back together here. The lubricant system, I have to put that back on and get it hooked up, and we should be ready to rumble with this thing and try it out. All right, well, I am so pleased, absolutely elated that I finally got these nice metal band wheels on here. They are working like a charm. I can't believe I went this long without making the switch. I knew that at some point I was going to invest in this, but you know, this here whole exercise that I've got going here is a hobby. So other people golf and they do things like fishing and whatever, and I cut lumber for fun. So that being what it is, I guess, you know, you should really spend more money on your hobby, right? Okay, so the Bandwheels, you know, you can look them up. Current price right now in 2020 is about $1,000 for these 25-inch Bandwheels, you know, give or take or whatever, for depending on what shipping is and all that stuff. But huge difference, because when I had the rubber tires on here, you could only put on so much tension. So I probably put on half, or maybe not even half the tension that I really wanted to put on here. And once you get up to that point and you start squishing the tires in on the rubber, then your blade wants to walk off the edge of the tire. So one of the things that people sometimes don't realize is that what keeps your blade on these wheels is the crown, and the blade always wants to walk up to the high spot on the wheel. So on here, you do end up having it towed just a little bit, and I think on some mills they might end up towing it a little bit differently because they don't have this bearing set up out front. I mean, my mill is built different than almost anyone else's because I've got pillow block bearings on both sides of the shafts, and so I've got you know, even there's no shaft deflection, if you will, when you tighten up the blade. If you have a wood miser or something else and the shaft is cantilevered out, and you tighten the blade, at some point there's going to be a little bit of deflection there that you have to deal with. What in the world? So there's going to be a little bit of deflection that you have to deal with there, and you have to account for that. And so that when you go up in tension, of course, it changes things a bit. Not so much with this one here because it's nice and even. Still has to be a little bit of a toe in because you want it to ride toward the front of these wheels here. So, you know, the edge of the wheel is about even with the bottom of the gullet on your blade. Anyhow, yeah, I can get up to the tension that I need. Well, this thing I can probably bust the blade if I want to. I don't know. I haven't really tried it, but it's got plenty of ability for tension. And I'll tell you, the difference is that it can cut like butter, and it cuts fast. Before I had to, you know, watch how fast I was pushing it through, just because with that amount of tension it would tend to dip and dive. And I was pretty meticulous about making sure everything was straight, but there's, you know, when you're dealing with rubber, there's only so many knobs you can turn to get everything just right. So here I've gone through, I've got everything nice and straight, and it makes a nice flat cut, perfect every time. You get a little bit more life out of the blade because your blade doesn't have to be so perfectly sharp to make a good cut. And so I'm expecting to, you know, at least double the life of each blade that I'm using here. And I'm also expecting to, you know, just get faster production, be able to slice a log up a lot faster. This stuff here I was going through at least twice as fast as before. Yeah, what else? Plus the fact that it just, you know, runs smoother. You don't have to worry about having your wheels balanced and everything for your sawmill, so which is kind of crazy, right? Other thing that I did on here recently is I added these stops here, and I just have a couple stops, and you can kind of flip these around, whatever you need to do. And then there's some stake pockets in different spots. I don't necessarily always need a stop in every spot. I can just pull one out and put it over there. So maybe one day we'll add hydraulics or something to that, but not super important right now. It's probably more fish to fry. What I had on here before was this thing here. So as we go along, we keep making little improvements on the mill, and it makes it better and more consistent and easier to use and all that. So this last upgrade here with the wheels was definitely well worth investment. And if you are thinking about building a mill, I would highly, 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 highly recommend investing in those wheels. Oh, the other thing that is super important about having these wheels is the amount of power that it takes to turn this. I can put this at full tension, over twice as much tension as I could before, and I can easily turn it. If I put it at the maximum amount of tension that I could run with the wheels before, which is, like I say, less than half, it was hard just by hand, okay? It was hard to turn this. So, you're losing a lot of power from that 40 horse motor into those wheels just to turn the blade and to, it's like running a car with a flat tire on the road, right? So this turns way, way easier. I had a guy comment a while back, because I've got some pulleys on the other side. And if you look in this design, it's like, oh, there's some pulleys on there, and those must really take a lot of power. Well, that I can say with assuredness, that those pulleys took nothing for power. Those belts take nothing for power compared to what the wheels took. And this just runs so much smoother. I'm running at about 65. I clocked it with a tack, and I'm running about 65 miles an hour as far as the blade speed goes. So that kind of gives you a reference point. And at some point, if maybe I'll go back into doing some stuff to talk about blade tension and all that, but really there's some great videos on the Cook's Saw YouTube channel, and so I don't necessarily need to duplicate what they've already got done, although sometimes it's interesting to do. Anyway, yeah, that's it. Thanks for watching. We'll see you around.